Hello everyone, welcome back to another lesson on measurement. Today we are going to be looking at volume. Before we get going, let's have a look at our concept map for today. Cool everybody, so before we get into volume, I am going to define what a polyhedron is. After I've defined that, I'm going to define volume. Shortly after defining what volume is, I'm going to show you how we can actually calculate the volume of rectangular prisms, cubes, and cylinders. So, what is a polyhedron? A polyhedron is a three-dimensional figure with four or more flat surfaces. So, everyone, a polyhedron is essentially any three-dimensional shape. We know that we get two-dimensional shapes, which is essentially if I were to draw a circle or a square on a flat piece of paper. That is two-dimensional. Three-dimensional shapes are essentially shapes that I could hold. So it could be a ball, it could be a can of beans, could be a box of chocolates. But essentially, a polyhedron is a three-dimensional shape that has multiple surfaces. Great, let's go to the next slide. So let us define volume. So the volume of a three-dimensional shape refers to the capacity that the shape has. The volume of a three-dimensional shape is determined by working out the area of the base. And once we have the area of the base of the object, we then multiply it by the perpendicular height. So please just make sure that you're comfortable with the idea of me working out the area of the base of the shape, and I multiply it by the perpendicular height. I'm going to put a red box around perpendicular because, just a reminder, with some three-dimensional shapes, I have a slant height. My slant height is not always my perpendicular height. So please make sure when you are calculating volume that this calculation is the area of the base times the perpendicular height. Also, just a little note that you might want to say to yourselves is if I'm working with shapes that involve perpendicular sides and 90-degree angles, we must look out for Pythagoras because we know that Pythagoras is common when we are working with right angles. Great, let's go to the next slide. The first shape that I'm going to talk about finding the volume of is the volume of a cube. So the volume of a cube can be found by multiplying the area of the base by the height of the cube. And we know that this is going to work, everyone, because cubes have 90-degree angles at each of their corners. So this height will be a perpendicular height. And we've said that we're going to find the volume of the shape by first calculating the area of the base. And my base is this bottom square. And what is the area of the base? Length times breadth, but because it is a square, all sides are equal. So the area of the base will be length times length. Then I multiply it by the perpendicular height of a cube. But again, because this is a cube, all of the sides are equal to each other, so my perpendicular height is actually going to be L again. So L times L times L is going to be the volume of my cube, so my volume is L cubed. Great, everyone. I hope that everyone is with me so far. So I'm going to say this a few times just so we make sure that we understand. The volume of a three-dimensional shape is calculated by finding the area of the base times the perpendicular height. For this one, I had calculated the area of the square at the bottom, and I multiplied it by the height of the cube. Great, let's go on to the next slide. Great, guys, so the next one is the volume of a rectangular prism. We first need to calculate the area of the base, which is the bottom rectangle. So we can see the base of this particular box is this bottom rectangle. So I'm first going to calculate the area of that rectangle. Once we have established this, we multiply the area of the bottom rectangle by the perpendicular height. Again, a rectangular prism is made up of rectangles, and rectangles have right angles present at all of their corners. So we know that that angle will be 90 degrees, which means that h is my perpendicular height. So let's write it as a formula. So the volume will be equal to the area of the base, which is length times breadth. And I'm going to be multiplying this by the perpendicular height. So the volume of a rectangular prism is length times breadth times height. Let's go to the next one. So we are now going to calculate the volume of a cylinder. The volume of the cylinder is found by establishing the area of the circular base and then multiplying this by the height. Again, it's going to be the perpendicular height. We can see this perpendicular height has been labeled specifically because we have this right angle present. Now, if I'm first going to calculate the area of the circle at the bottom, I have to use the radius. And just a reminder that the area of a circle is pi r squared. And I've now got the area of my base circle, and this is being multiplied by my perpendicular height. So it's going to be pi r squared times h, which I can also just write as pi r squared h. Just a note about this one, everyone, is please make sure that you are actually substituting in your r. In some questions, you might be given the diameter. We want the radius, and the radius is always half of the diameter. So the volume of a cylinder is pi r squared h, where r is the radius, not the diameter, and h is the perpendicular height. Great. After the break, we're going to be looking at how these volume formulas can help us solve some examples. See you soon. Welcome back, everyone. Before the break, I defined what a polyhedron is, I defined what volume is, and just a reminder, in case you've just joined us, the volume of a three-dimensional shape can be calculated by finding the area of the base and multiplying the area of the base by the perpendicular height. So please make sure that you know that that is the definition of volume, as it is slightly different to other definitions like surface area. Then we defined what the volume of a cube is, a rectangular prism, and a cylinder. Now we're going to get into some examples where we can apply what we've seen with volume. Let's go to the board. So the first question has asked us to calculate the volume of the rectangular prism. So we've got our rectangular prism present over here, and we have been given the three dimensions that are going to help us to achieve this. So let's just remind ourselves of how I'm going to actually calculate the volume of this shape. I always have to take the area of the base and then multiply it by the height. So the base is this bottom base rectangle, where we can see it has a length of 12 centimeters and it has a breadth of 3 centimeters. So I have first calculated the area of this rectangular base, and that is the first part of the volume calculation. I am then going to multiply it by the perpendicular height. Because I've been told that it is a rectangular prism, that means that all of these corner angles are actually at 90 degrees, which is good news for me because this means that this 4 centimeters represents the perpendicular height of the rectangular prism. So I'm going to have 12 times 3 Then I'm going to multiply it by 4. This means 12 times 3 times 4 is the same thing as 12 times 12, which is just going to give me 144 centimeters cubed. Please take note that I have cubed my units. Just a reminder, for area and surface area, my answer is always with the units being squared, but with volume, it will always be the units cubed. The cubed indicates that it holds a capacity, it holds a volume. So we've written centimeters cubed because it is a capacity. So please remember that, keep that at the back of your heads. I really don't want you to lose a mark because you forget the cubed. So centimeters cubed. Great, let's look at the next example. So we are now going to calculate the volume of this specific cube. Now, before anyone gets worried, it might look slightly overwhelming that there's only one measurement present on the cube. But what is a cube? A cube is a three-dimensional figure made up of squares. And I know that all squares have equal sides. So that means that each of these sides, everywhere you look, each side is 5 centimeters. So with measurement questions, please make sure that you read your question carefully, because the fact that this is a cube is your immediate first clue that I actually know what my dimensions are of my shape. So the volume is the area of the base, and I've got a square base, and the area of a square is length times breadth, so it's going to be 5 times 5. And volume is always the area of my base times my perpendicular height. And squares have right angles at all of their corners, so that means that this height present over here is perpendicular to the base. So the perpendicular height is 5. So the volume will be 5 times 5 times 5, which is just 125. But am I done, guys? Can I leave my answer like that? I'm hoping there's some shaking of heads. No, I've forgotten my units. So it's going to be centimeters. Is it going to be squared or cubed, everyone? Cubed, because it holds a volume, which means it can hold a capacity. Let's look at the next part of this question. So it says if each side of this cubed was decreased by 1 centimeters, what would the new volume of the cube be? So this question is essentially asking us to look at what we've been given. We've been given a cube where each side is 5 centimeters. Now they've said 1 second, hold a second, wait up, we're now going to decrease each of the sides by 1 centimeter, and we're going to have to calculate the volume according to this decrease in size. So if each side is originally 5 centimeters, we know that if we remove 1 centimeter, all of the new sides will be 4 centimeters. So let's see what our new volume will be. So it's no longer 5 centimeters. We now have 4 centimeters for each side. So that means again that each measurement will be 4 centimeters because it is a cube, which means that all of the sides are equal to each other. So I first find my area of my base, which is the square at the bottom. Length times breadth will be 4 times 4. And then we are going to multiply the 4 by 4 by the perpendicular height. And the perpendicular height, we again know that it is a right angle because it is a cube made up of squares. The perpendicular height is 4. And 4 times 4 times 4 will give me an answer of 64 centimeters cubed. Great, I hope everyone's with me. Let us go on to our next example. So we are first going to calculate the volume of this cylinder. Please note, guys, it will be given that this is a perpendicular height, and you will be needing to look out for the fact that it is the perpendicular height. So we're going to calculate the volume of the cylinder. We've been given the radius and we have been given the perpendicular height. So let's do this calculation. So we know that the volume of a cylinder will first be calculated by taking the area of the base. My area of my base is pi r squared, because that is the area of a circle. My radius is 3 centimeters, so it's going to be pi times 3 squared. So I first found my area of my circular base, where my radius is 3 centimeters. I'm then going to multiply this by my perpendicular height, which is 8 centimeters. Wonderful, guys. So now we are going to need our trusty friend, the calculator. So we are going to type in pi. Just a reminder how to get the pi on your calculator. You press shift and then you press the button that says times 10 to the power of x at the bottom, and that gives you your pi. So it's going to be pi times 3 squared times 8, which gives me 72 pi. But if I want to simplify this into units, I press my SD button, and it's going to give me 226,19. And I've rounded to the second decimal place. In your test, you'll be following the instruction with regards to the rounding that you need to use. So it's going to be 226,19 centimeters cubed. Again, we're saying cubed because this is a volume. It has a capacity of 226,19 centimeters cubed. Great. Let's have a look at the next example. So we have been given a can of cool drink. You can imagine whatever cool drink it is. Maybe you have a favorite one, so you can keep that in the back of your heads. And please stay with me and don't get distracted about the thought of a soda. So a can of cool drink has measurements as shown in the figure. So we have 11 centimeters for height, and we have a diameter of 7 centimeters. So we're first going to determine the volume of the can. After we've determined the volume of the can, we are going to see how many cans can be packed into a box with a length of 28 centimeters, a width of 21 centimeters, and a height of 22 centimeters. Great, everyone. So this question has two parts. I'm first going to calculate the volume that my can of cool drink can hold. Then we've kind of been thrown a bit of a curveball. I've been given a box, and I want to know how many cans of cool drink can I actually fit into my box. So we're first going to work out the volume of the can. Then we're going to see how many cans will fit in my box. So let's do the calculations together. So determining the volume of this can be done by first finding the area of the base and then multiplying it by the height. My base is a circle, and I have been given the diameter. But this is going to cause a problem because my area of a circle is pi r squared, and the volume is multiplied then by the height. But my issue is it's an r. I've been given the diameter. I cannot substitute in my diameter in place of r. But can I find my radius from my diameter? I can, because the radius is half of the diameter. So I know that my radius will be equal to 3,5 centimeters. So my volume will be pi times 3,5 squared multiplied by my height, which is 11. Great, so let us pop this in our calculator. So we're going to type in pi times 3,5 squared multiplied by 11, which is going to give me 539 over 4 pi. But I want to be able to write this with respect to the second decimal place. But guys, please make sure you read your instructions on your test. to check if it's you rounding to the first decimal place or the second decimal place. And I'm going to have 423,33. I'm rounding it off to comma 33 because there is a 9 to the right of the 2. So 423,33. Cool, guys. So we know that the volume of this particular can is 423,33 centimeters cubed. Let's go on to the next part of this question. Great, everyone. So the second part of this question, I'm just going to repeat it again for us. So it's how many cans can be packed into a box with a length of 28 centimeters, a width of 21 centimeters, and a height of 22 centimeters. So before we actually start with this example, I'm going to ask us to actually imagine this box, and we are going to think about the dimensions of it. So we've got a length of 28, we've got a width of 21, and we have a height of 22. So what I'm going to ask everyone to think about is, with regards to each dimension, how would I be able to actually fit this specific can in? So if I'm focusing on the length first, we've got 28 centimeters. And if I'm going to be packing my cans vertically, I want to see how many I could fit lengthwise. So if my diameter is 7 centimeters, I would be able to fit 28 divided by 7 into the length of this box. So it's essentially saying how many cans across would fit. And 28 divided by 7 gives me 4. So I know along the bottom length of this box, I will be able to fit 4 cans. Now I'm going to look how many cans would fit with regards to the width of the box. So we're now talking about that 21 centimeters. So let's look at the width. So we're going to have 21 centimeters, but the cans are being packed vertically. So again, we're going to be using my diameter because we want to see how many cans can go across the box. So everyone, if you're struggling to visualize the box, just imagine it's a box of cool drinks and the cans are being placed into it. So I know that the diameter is going to affect how many I can put along the length and the width of the box. Because if I'm packing them tightly next to each other, the widths of the can matter because I need to know how many I'm actually going to fit into the box. So let's see how many we're going to be able to fit along the width together. Great, everyone. So because the width of the box is 21 centimeters, I'm going to divide this by 7, which is the diameter, and 21 divided by 7 is going to give me the fact that I can fit 3 cans along the width of the box. Now let's have a look at how the height is going to be affected. My height is 22 centimeters, but my cans themselves have a height of 11 centimeters. So that means I can fit 1 can on top of the other. So that means that I'm going to have 22 divided by 11. We're dividing by 11 because the height of the can is 11. So we're going to be able to stack 2 cans on top of each other along the height of the box. Lastly, I need to see how many cans will be packed in total into the box. And I'm just going to multiply these 3 values together, because I know that those are the dimensions of the box, so it will account for how many cans I can fit in. So it is just going to be 4 times 3 times 2. 4 times 3 times 2 is 24. So I can fit 24 cans into my box. Welcome back, everyone. Before the break, we looked at the volume of cylinders, cubes, and rectangular prisms. In this next part of the lesson, we are going to be looking at the volumes of some different types of shapes. But let's first have a look at the concept map together. So I'm going to remind everyone what a polyhedron is. Then we're going to remind ourselves what volume actually means. Then we're going to move on to defining the volumes of triangular prisms, pyramids, spheres, and cones. So just a reminder about what a polyhedron is. A polyhedron is a three-dimensional figure with 4 or more flat surfaces. So everyone, just a reminder, a polyhedron is a three-dimensional shape. It's not a two-dimensional shape. A two-dimensional shape is something that can occur on a flat surface. So if I were to draw a triangle on the board behind me, that is a two-dimensional shape because it is drawn on a flat surface. But a polyhedron is a three-dimensional shape. So it's something that I could possibly hold. So you could hold a soccer ball. You can hold a box of chocolates. So three-dimensional has multiple faces, and we are able to calculate the volume of polyhedrons. Let's remind ourselves about volume. The volume of a three-dimensional shape refers to the capacity that the shape has. The volume of a three-dimensional shape is determined by working out the area of the base of the object, and then we multiply it by the perpendicular height. So the volume is calculated by first establishing what the base of the shape is, and we then multiply it by the perpendicular height. Please make sure that you always check that you know which height you've been given, because there is a chance that you might have to first calculate the perpendicular height. Let's go to the next slide. So if I'm first going to be calculating the volume of a rectangular pyramid, the volume of a rectangular pyramid can be found using V is equal to 1/3 of the area of my base times my perpendicular height. So this is where A represents the area of the base and H refers to the height. Please make sure that you use the correct measurements in this calculation. So I'm first going to calculate the area of this base, then I'm going to multiply it by the perpendicular height. There is a chance that in a question they may provide you with the slant height. The slant height is not necessarily the perpendicular height. So we must always make sure that we are using the perpendicular height in my calculation. Let's go to the next slide. So the volume of a triangular pyramid can also be calculated using 1/3 times the area of the base times the height. Please note that the A represents the area of the base triangle. So I'll first have to find what the area of this base triangle is, and then I will multiply it by the perpendicular height. Cool. And just a reminder, for triangles, we generally find the area by saying 1/2 times the base times the height. Let's go to the next slide. So if I'm going to be calculating the volume of a sphere, we take 4/3 pi r cubed. The things that I do want to point out for this particular example is that the formula is using radius. So please make sure on your diagram you know what the radius is, because we know that the diameter is 2 times the radius. So if you are given the diameter, you have to first divide the diameter by 2 before substituting into the formula. But if you are given the radius, you can substitute straight into the formula. So the volume of a sphere is 4/3 pi r cubed. If you're curious about why the r is cubed, just remember that all of my units for volume will always have a cubed involved. Let's go to the next slide. If I am finding the volume of a cone, I take 1/3 pi times my radius squared multiplied by my perpendicular height. Again, I'm going to make a similar point. Please make sure you are using your radius, and please make sure you are using the perpendicular height. If you are given the slant height, you will first have to calculate the perpendicular height of the cone before substituting into the volume formula. But let me ask you, if I, for instance, gave you the slant height and the radius, is there a way that I could find the perpendicular height? I'll give you a second to think about it. If I give you the slant height and the radius, is there a way I could find my perpendicular height? Yes, I'm hoping that we've got some people saying Pythag. So Pythagoras can help me calculate the perpendicular height, because we know that Pythagoras allows me to find the sides of right-angled triangles. Let's go to the next slide. So the volume of a triangular prism, the area of the base will be multiplied by the height. But because this is a triangular prism, we know that it will have identical triangles at the base. So we'll have triangle A as well as triangle B. So you'll be able to choose which base you want to calculate because they'll be the same. So it will be the area of the triangle or the triangular base multiplied by the perpendicular height, and the perpendicular height will be given to you in the example. Great. So everyone, I'm hoping that everyone is okay with those definitions, just as long as you keep in mind that the volume is the area of the base multiplied by the perpendicular height. After the break, we're going to be looking at some practical examples of how to apply these formulae. See you later. Welcome back, everyone. Before the break, we reminded ourselves about the definition of volume. We also defined the volume of certain polyhedrons, and a reminder that a polyhedron is a three-dimensional figure. So in this part of the lesson, we are going to actually be working through some examples of volume. Let's look at the first one together. So we have been asked to determine the volume of this specific figure. If we have a look, we can see that we have a rectangular pyramid. Just a reminder that we define the volume of a rectangular pyramid to be 1/3 times the area of the base multiplied by the perpendicular height. So let us get going with this calculation. So let us just write the definition for the volume of a rectangular pyramid again. The volume is equal to 1/3 times the area of the base multiplied by the perpendicular height. So first things first, everybody, I need to know what the area of my base is. Well, what is my base? It is a rectangular based pyramid. So this means that my pyramid base is a rectangle. And how am I going to calculate the area of this rectangle? Well, I know the area of a rectangle can be found by saying length times breadth. So we're going to have 5 times 2. So far, the volume of this figure is going to be equal to 5 times 2. We then know that it is going to be multiplied by my perpendicular height. In this case, please note that I actually have been given the perpendicular height. I've been given this right angle. In the next example we're going to do just now, we're going to see what actually happens when you're given the slant height. But because I have been given the perpendicular height, it means I can substitute it straight into my formula. So I'm going to have 1/3 times 5 times 2 multiplied by the perpendicular height of 13. I'm going to simplify my bracket. So I'm going to have a third times 10 times 13. So I'm going to have a third of 130. Now we are going to substitute this into our calculator. So we've got 1 over 3 being multiplied by 130. And that's going to give me 43,333, so we can see the 3's recurring. If I round to the second decimal place, I'm going to have 43,33 centimeters cubed. I just want to make another note about the units being cubed, just in case you've only just joined us now. Please remember that the units for volume are always cubed. For area and surface area, the units are squared, but because volume refers to the capacity that a three-dimensional shape can hold, the units will always be cubed. So just want to highlight that and just make sure that I remind you of that for examples when doing measurement. Great, let's go back to the board. My next example is asking me to determine the volume of this specific figure. Now, you might say, well, ma'am, this looks very similar to the example I just did. But there is a difference. The main difference is that we have not been given the perpendicular height. We have been given the slant height. So 13 meters is my slant height. And this is going to be an issue for me. Also, something that I do want to note is that it is actually going to be 13 centimeters for the height. I don't know why it says meters. That is a typo. I'm going to ask you to calculate it with 13 centimeters, please. Great. So let's go into the calculation. I'm just going to correct the typo. We want it to be 13 centimeters, please, everybody. Great. So if I'm going to determine the volume of the figure, it's going to be a third times the area of my base multiplied by my perpendicular height. The area of my base is going to be the area of my rectangle, which is my base that is given over here, which is 12 centimeters by 10 centimeters. So the volume is equal to a third times the area of my base, which is 10 times 12. And this is going to be multiplied by my perpendicular height. But I do not have my perpendicular height yet. I only have my slant height, which is 13 centimeters. And I do not have essentially AG. I want to know what AG is, because AG is my perpendicular height. The question is, how am I actually going to find AG? I'm hoping that everyone's going to have a bit of a think at home on if there's any way that I can actually find AG. Well, we are looking at an example of Pythagoras, because we've got a right-angled triangle within this specific pyramid, because we can see that the perpendicular height will be AG, FG will be my base, and I can see that my hypotenuse is in fact 13 centimeters. So if I'm going to be calculating my perpendicular height, we can say that AG squared will be equal to 13 squared, because that's my hypotenuse squared, minus 5 squared. And the reason why I'm saying minus 5 squared is because FG is half of 10 centimeters. So the base is going to be 5 centimeters, because we know that the perpendicular height will occur in the middle of the rectangle. So if the perpendicular height's in the middle of the rectangle, that means that FG will be half of CB. So if I do Pythagoras, I'm going to have that AG squared is equal to 169 minus 25. which means that AG squared will be equal to 144, which means that AG is equal to 12 units. So, just a note, please make sure over here that you write Pythagoras' name in brackets, because we always have to give him credit for his working. So my perpendicular height is actually, in fact, 12 centimeters. So let's plug this all into the calculator to find out what the volume of this triangular pyramid is. Rectangular pyramid, sorry guys. So we're going to have a third multiplied by 10 times 12 times 12. So we can see that this rectangular pyramid has a volume of 480 centimeters cubed. Again, just a reminder, I've said cubed because it is the volume calculation. Let's go to the next example, everyone. So I have now been asked to determine the volume of this specific cone. What have I been given? I've been given my radius and I've been given my slant height. So again, everyone, I'm going to remind you that it's very important that I know what type of height I have been given. I've given you the slant height, but for volume calculations, I need the perpendicular height. So I'm going to ask you, if I want the perpendicular height and I've been given the radius and the slant height, is there a way for me to get the perpendicular height? Great, so if I look at my cone, I've got the right angled triangle present, and I'm going to use Pythagoras to find my perpendicular height. So the perpendicular height squared will be equal to the hypotenuse squared minus the radius squared. So we always say the hypotenuse minus one of the sides squared, and this is because of Pythagoras. Now, to find out what an expression for h squared, I'm going to use my calculator. Great, so I have 25 squared minus 7 squared, which is going to give me 576. 576. Then if I square root that, it's going to give me 24. So I'm going to have a perpendicular height of 24. So I can now fill in the information for my volume. So I've got a third pi multiplied by my radius squared multiplied by my perpendicular height, which I found using Pythagoras. So we know that this is 24 centimeters. Let us plug this into our calculator. So it's a third multiplied by pi multiplied by 7 squared multiplied by 24, which is going to give me 392 pi. And if I want to round this off to the second decimal place, we're going to press our SD button. So it's going to give me 1,231,50. And I'm saying centimeters cubed because it is a volume calculation. So the volume of this specific cone is 1,231,5 centimeters cubed. Great, everyone. I hope that you're still with me. Let us go on to our next example. So we are now going to be determining the volume of a sphere that has a diameter of 17 centimeters. Now, I'm hoping that everyone's immediately got little alarm bells going off in their head the second I see the word diameter. I have to remember that I'm often needing to use my radius in calculations for volume. So because I've got the diameter, it should be almost like a little bit of a clue that there has to be a step that comes to find the radius before I actually find the volume of the three-dimensional shape. So let's go to the board together and see what I mean by saying that. So the volume of a sphere is 4/3 pi times r cubed. And because it is multiplied by r cubed, I have to address the fact that I've been given a diameter of 17 centimeters. If I substitute in 17 in the place of r, my volume is going to be so much larger than it needs to be, everyone. So please make sure that you first write down what your radius is. And I know that my radius is always my diameter divided by 2. So what is my radius? It is going to be 8,5 centimeters. This is good news because now I can actually substitute into my formula. So it's going to be 4/3 pi multiplied by 8,5 cubed. Let's get our calculator. Great, so it's going to be 4/3 pi multiplied by 8.5 cubed, which is going to give me 4913/6 pi. And if I want to write this correct to the second decimal place, I'm going to press my SD button, which is going to give me 2572,44. And please remember that I have to include my units. And my units will be centimeters cubed. So the volume of the sphere is 2,572,44 centimeters cubed. Great, everyone. I hope that you've enjoyed our lesson on volume today. I really hope to see you again sometime soon.